All right, folks, we're going to discuss the tabular method, and you are fortunate that on your final this year, you can use this method instead of the full integration by parts method. So let's get started. To start this method, we're going to write 3 columns down. We're going to write the word sine, and then we're going to write D for derivative and I for integral. For sine, notice how it goes a positive f of x times g of x and then a minus. So we're going to follow that same pattern and go plus and then minus, plus and then minus. And you may have to keep going, you may not. I'm going to just stop there for now. Now for the D for derivative, you're going to put what you usually put for your f of x. So here we know that we would choose x squared. And what you're going to do is keep taking the derivative down until you get to 0. Remember, that's how we chose f of x. We chose the function that when we took the derivative of it over and over again, it would eventually get down to 0. Now folks, once you get to 0 here, you don't have to keep going, you can stop there. Then I'm going to put my g prime of x here. So in that case, this is going to be my e to the x. So this is going to be e to the x. And then I keep integrating. So integrate e to the x and I get e to the x. Integrate again, e to the x is e to the x. Integrate that and I get e to the x. Now what's our solution? Well, our solution is going to be what we circle, and we circle diagonally. Okay, that plus is going to be with that. I'm going to circle this way. That minus is going to be with that. And then I'm going to circle this, and you'll notice that the 0 doesn't end up getting circled. So my final answer is going to be a positive, because see that positive right there, a positive x squared e to the x minus a 2x, see how I'm combining these two things, a 2x e to the x, and then now I'm back at a positive 2e to the x, and don't forget your plus c. And folks, that's it. We're done with the tabular method for this problem. So again, to summarize, you write sine, and you write plus minus, then you write d for derivative, I for integral. You write down your f of x here under your d, and you take the derivative of it till you get to 0. Then you take your g prime of x and you write it down here, and you keep integrating it until you get lined up with your 0. Then you do your circles diagonally, and you use your signs to help you write your final answer. All right, here's our example 8 now. So again, I'm going to write sine, and then I'm going to write D and then I. So my sine is plus, minus, plus, minus. My derivative is going to be of x, which is going to be, derivative of that is 1 and then 0. So it looks like I went a little too far, so I'm going to erase that minus. The integral is going to be sine x. Integrate sine x and I get a negative cosine x. And if you don't trust me, I always like to check in this direction. Is the derivative of a negative cosine x sine x? Yes, it is. And then the integral of a minus cosine x is a negative sine x. All right, now I'm ready to go ahead and circle. And notice how I don't circle the top right thing and I don't circle the bottom left. So my final answer is going to be a positive x times minus cosine x, and then a minus, so I write down minus, and then I've got 1 times a negative sine x. Now let's go ahead and kind of simplify that, rewrite that. That's going to be a minus cosine x times x, or I'm going to maybe put the x out in front, so minus x cosine x. And then this is actually going to end up being a plus because the minus become a plus. This will just be plus sine x. and then we'll have plus c. So folks, don't think that just because there's a positive first that this will end up being positive. It just means that it's going to be a positive whatever this times this is, and then a minus whatever this times this is. All right, let's try some harder ones now. Now you can see with this particular problem, it's going to take us a little bit longer to get down to 0. And the reason why is if I take my derivative of x cubed, it's going to be 3x squared, then 6x, and then 6, and then 0. So I'm actually going to have to go plus, minus, plus, minus, plus. Now I'm going to integrate sine x, which is going to give me a minus cosine x. Then integrate this, and I get a negative sine x. Integrate negative sine x, and I get cosine x. If you don't believe me, what's the derivative of cosine? It's negative sine. And then I get a sine x. Don't believe me? What's the derivative of sine? Sine of x is cosine x. Remember, Santa Claus is good. All right, at this point, we're going to do our circles. So I'm going to circle this, here, and there. So I'm going to have a positive x cubed times negative cosine x minus, see I write down my minus, and now I'm going to have 3x squared times a negative sine x. Okay, now I have a plus 6x cosine x. And then last but not least, I have a minus 6 sine x. Okay, I'm going to go ahead and kind of simplify here. I'm going to bring that negative out in front. So that's going to give me a negative x cubed cosine x. And then this is going to become a positive because the minus minus becomes a positive. 3x squared sine x. Then I've got a plus 6x cosine x. And then minus 6 sine x. And then a plus c. Throw that in there. So certainly not like the hardest thing in the world, but it can be tricky to integrate multiple times here. All right, this is an important problem here, so don't turn off the video now. What we're going to do is do the same setup, except unfortunately, these problems are going to be a little bit more difficult because of the integral of our trig function. All right, so we're going to write sine, and then we're going to write d or I, and then this is going to be plus minus, plus minus, and I'm going to have 4x be my derivative. Take the derivative of that, you get 4. Take the derivative of that, you get 0. So I can erase that minus. Now the hardest part of this problem, like I said on the previous slide, is going to be integrating. So I've got sine of 5x. The integral of that is actually a negative 1/5 cosine of 5x. Well, why did I want the 1/5? Well, that's because when you take the derivative of cosine, you get a negative sine. Well, that's what the negative here helped me with, so I could get a positive sign. But then we keep our baby, so that's a match here. But don't forget we have to take the derivative of our inside function. So the derivative of this is 5. So if I put a 5 out in front, that's exactly what I want. I want those 5s to cancel so that I'm left with just a 1 in front here. If you want, you could actually do that whole problem with u substitution if you wanted. Now, how do I integrate this? Again, you could do u substitution, but you might find this pattern that this is going to be negative 1 over 25, and that's going to be sine of 5x. If you don't trust me, let's take the derivative of this. This derivative of sine is cosine. Keep your 5x. Okay, don't forget I had a negative 1 over 25 out in front. And then don't forget to take the derivative of our inside, which is 5. How does this simplify? Well, that would give me a negative 1/5 cosine of 5x, which is a perfect match. So we can definitely take time in class to make sure that you guys know how to find the integral of both this function and that function. All right, now we are definitely ready to write the answers here. So let's do it. We're going to have a positive 4x times the negative 1/5 cosine of 5x. And then we're going to have a minus 4, and then we're going to have a negative 1/25 sine of 5x. So let's go ahead and let's simplify that. Well, 4x times a negative 1/5 is going to be a negative 4x over 5. And I'm just going to write that as cosine 5x. And then a negative 4 times a negative 1 over 25 gives me actually a positive 4 over 25. And then you're going to have a sine of 5x plus c. And that's it. That's your answer. Folks, I do have one more. Stay with me. It's worth it. It's worth your wait. All right, last one. So I'm going to write this as a sine plus minus plus, and then I'm going to take the derivative of x, and that's going to be 1, then 0. And now I need to take the integral of e to the 2x. Well, that's going to be 1/2 e to the 2x. How come? Well, if I take the derivative of e to the 2x, I get e to the 2x times 2, because the derivative of the inside is 2. So that's why I need the 1/2 out in front, so that the 2's can cancel and I'm left with e to the 2x. Again, I am going to discuss that in class some more because I think it's tricky. And the integral of this one is going to be a 1/4 e to the 2x. And if you don't believe me, derivative of 2x is 2, so you'd have 2 times 1/4, which would give you this. If you're confused by that, I certainly want to slow down and talk about that in class. So our final answer here is going to be this and this. So this would be a positive x times 1/2 e to the 2x, and then a minus 1 times 1/4 e to the 2x. So how do I go ahead and simplify that? That would be x over 2 e to the 2x. And then this here would be a negative 1/4 e to the 2x. Don't forget your plus c. Thanks for watching that whole video. You're a superstar. See you later.